Hello and welcome back to Math Class in Session. More maximum and minimum problems. Example, an apartment building has 50 units. When the rent is $900 a month, all the units are occupied. But every time they raise the price by $25 in rent, one unit becomes vacant. On average, all rented units, that is, require $75 in maintenance and repairs each month, on average. So how much rent should the real estate office charge to maximize profits? Oh, it's a profits question. Solution. Let X represent the number of $25 rent increases. So, profit is revenue, take away costs. Anybody who's run a lemonade stand understands that the profit, the money you get to keep, is the money that comes across the table. Take away the cost of making the lemonade. Now, where does revenue come from? If we're renting apartments, it comes from sales times price, or rented units times price. And then the cost is, well, it says $75 for every rented unit. And the sales, or the number of rented units, is, let's look into the paragraph, 50. Take away 1 for every time we raise the price. So it'll be 50 take away X, because X represents the number of times we change the price. So these sales are 50 take away X, while the price is currently 900, but it's going up by $25 every time we change the price. So this price is 900 plus 25X. Sales are all 50, take away the empty ones. And there's one empty one for every raise in price. We see that we have the word sales in our work. And below that, we have 50 minus X, because 50 minus X is the number of apartments that are rented. So 50 minus X is the number of sales. And so if sales is 50 minus X here, sales must also be 50 minus X here. Having developed this expression for profit, we have to multiply it out and collect like terms. That's an exercise I'm going to leave to the student. Pause the video, multiply it out, and arrive here. Once we've arrived here, we can now state that it's a parabola, it opens down because of the negative, and it therefore has a max. And that maximum profit, because this is the function for profit, that maximum profit will exist when X is what it is at the vertex. At the vertex of this parabola, we know that X is always negative b over 2a. X being negative 425 over 2 times negative 25, right here. Negative b over 2a is 8.5. And so we can conclude that profit is maximized at the vertex, and that happens when X is 8.5, and we look to see what X represents. It represents the number of $25 increases. So we can conclude the rental company maximizes profit when either 8 or 9 of the units are vacant. Another one. It costs a bus company $225 to run a minibus on a ski trip. That $225 might be gas, it might be border crossing charges, it might be licensing fees. It costs a bus company $225 just to run a minibus on a ski trip, plus $30 for every passenger on the bus. I take it they're giving them a meal and possibly some drinks, and they're servicing the customers on the bus. It's a luxury bus, and this is how they run it. The bus has seating for 22 passengers, and the company charges $60 per person if the bus is full. However, for each empty seat, the company increases the ticket price by $5 per person, to maximize profit from the trip. Again, it's a profit question. Solution. Let X represent the number of price changes, which is the same as the number of empty seats, because there's going to be a price change for every empty seat. So let X represent the number of empty seats. And we know that profit is revenue, take away cost. And revenue comes from sales times price. This is where money comes from into a business. And cost, well, I went subtract, I made a square bracket, I made a basket, and into that I'm going to put all the costs. Looking into the paragraph, I see there's a fixed fee and $30 for every sale, for every person. It says it right here, $30 per passenger. Now the number of sales will be the full 22 passengers minus the empty seats, and X represents the empty seats, so the number of sales will be 22 take away X. Meanwhile, the price is $60 per person, but it's going up $5 for every empty seat. That's where we get this expression for price. Having developed this, all we have to do now is the math chores. That would involve expanding and simplifying, like math students have been doing for several years. Expanding and simplifying and collecting like terms brings us to minus 5x squared plus 80x plus 435. Now, I recommend, and strongly so, that a student pause the video, take this expression, do the chore of finding that this is correct. Yes. Having done that, it's now a fairly simple matter to go x equals negative b over 2a at the vertex. After all, this is a parabola that opens down and has a maximum profit, that is. And so the vertex is at negative b over 2a, so it will be negative 80 over 2 times that number. And that turns out to be 8. The company maximizes profit when there are 8 empty seats. A last example, a farmer has some fence in his barn. He has 450 meters of fencing in his barn to enclose a rectangular area, possibly for his cattle, and divide it into 2 sections as shown. And I've shown a length of the rectangle and a width of the rectangle, and it's divided into 2 sections. So there's fence along here too. Determine the length and width that yield the maximum area for the field. Now, when we're doing max-min questions, we seek an expression for the thing we're trying to maximize. Now, it says maximum area, so we want A equals. Solution. Well, first, there's 450 meters of fence. So this 450 must be all the fence. We have a length, we have another length of fence, and we have 1, 2, 3 widths, because fencing goes along this division as well. So 3 times that width and 2 times that length has to come up to 450. Now we know we're going to have to isolate one of these variables, so we could isolate L. It's also possible to isolate W. But if you isolate L, we'll drag the 3W across the equal sign, make it minus 3W, and then divide by 2. And we've isolated length. Here we go with the expression for the thing we're trying to maximize. Area is length times width. But length is this expression with a W in it. So replace that. L has become this expression. Multiply the W in to that expression, so it will be 450W minus 3W squared. It multiplies into the numerator. And we can split a 2-term numerator into 2 pieces. This could be minus 3W squared over 2 plus 450W over 2. So it's minus 3W squared over 2 plus 450 over 2 is 225W. And here we have our quadratic. It's a parabola. It opens down. It therefore has a maximum value. And that maximum value is always the same, negative b over 2a. A here is negative 3 over 2. And 2a, the 2's would cancel, and because 2 times 3 halves is just 3. So this is going to be x, or w, is equal to negative b over 2a, which is negative 3. Perform division, and we have the width is 75 meters. And the length will come from this expression, because we'll sub in 75 right there, perhaps on a calculator if necessary. For maximum area, the width is 75 meters, and the length is 112.5 meters. Confirm that last number for yourself.